Okay, let's go. Here we are on task 3 of the week. Volume by discs and washers. We begin. Page 463, number 9, says, well, it gives you the curve. Y equals x to the 2/3, that's the bird. And specifically, okay. Set up and evaluate the integral that gives the volume of the solid formed by revolving the region about the y-axis. And here they don't describe the region in words because there is a picture. So I'll reproduce the picture here. We take the curve y equals 2/3 on the interval 0, 1, and okay, it's a bird, so it looks kind of like that. And the area, the region under discussion is this one. So it's all of this, this region. Okay, and well, what are we supposed to be doing with this region again? We are supposed to be rotating it about the y-axis. So here is where I'm going to be pretty forceful about a recommended plan to stay kind of organized. I think you should draw a neat, high-quality picture, label relevant points on your curve, label the curves themselves. This is y equals x to the 2/3. Shade your region, and now always indicate the axis about which we are rotating. Here we are rotating about the y-axis, so you draw a little rotation symbol there. Okay, so if that's the case, then what shape is going to be formed? Well, it's going to be this kind of shape like this, where there's this little so sort of a kind of a cyclone sort of thing. Okay, so what is the volume of this kind of cyclone thing? Well, we can calculate the volume if we can find, if we can split it up into an infinite number of tiny pieces that we can find the volume of individually. And here the thing to do is to slice this this shape horizontally. If we slice this shape horizontally, then all of the little pieces are all going to be basically circles, right? Or circles with a tiny bit of thickness. So technically they are cylinders. Cylinders which are very, very short. And so, okay, I don't want to go into all this again, but basically we partition the y-axis from 0 to 1 up into subintervals, and we take one subinterval and we draw in the representative rectangle, and we are looking for the volume of one of these infinitely thin slices, and well, to do that, we can think of that slice as being formed by this rectangle being rotated about the y-axis. And so when we rotate this rectangle about the y-axis, what we get is a cylinder. What matters for our purposes is what the radius of that cylinder is. And so if you give me an arbitrary y value, I need to be able to tell you what the length of that representative rectangle is. And here we see that having our curve described as y equals x to the 2/3 is like inappropriate, because we need to transform this into an x equals equation. So if I raise both sides to the 3/2, then I get x equals y to the 3/2. And that is the way I want to describe the curve, because now I have a formula which gives me, for a particular y value, what the x coordinate is. And the answer is it's that number to the 3/2. Okay, and so now the way to think about this intelligently is you take an arbitrary y value. Y to the 3/2 represents the height of that representative rectangle. So now, when that representative rectangle gets rotated about the y-axis, a circle is formed. And what's the area of that circle? Well, the area of that circle is just pi r squared. So it's going to be pi, that number squared, gives the area of the circle formed when that rectangle rotates about the y-axis, and then we multiply by the height of that infinitely thin cylinder, which is just dy. This expression gives us the volume of one of those tiny infinitely thin cylinders. and then what I need to do is add up all the volumes of all those infinitely thin cylinders, and that's what integration can do. So we integrate up the y-axis from 0 to 1, and that's it. Okay, so that was the hard part, I think, is all the understanding. Now we have this integral to do, which I think is quite easy, because when you raise 3 halves, when you square y to the 3 halves, you just get y cubed. And I pull out the pi, and so now I just have this problem to do, and I can do this easily. When I differentiate y cubed, I get y to the 4th over 4, evaluated at 1 and 0, and that's just going to be 1/4. So I guess the answer to this is just pi over 4. I think that is right.
And I'll just double check all these because it seems like a good thing to do, but yeah, there it is.
Okay, 1 down. That was like easy. You might even say like sort of very easy. Okay, let's do number 13, which automatically suddenly already just gets really hard. So, what is 13? 13 gives you 2 parabolas. Okay, I actually did this problem on the Zoom call, and I asked you to do 13A and B. So 13, the directions for 13 were find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the given lines. And so the first one we're revolving is about the x-axis. So we're given 2 curves. The curves we're given are y equals x squared and y equals 4x minus x squared. And these 2 parabolas together define a region. It's the region enclosed by these 2 curves. So let's just establish that first. What is the region enclosed by these 2 curves? Well, okay, this can be rewritten as x 4 minus x, or perhaps even better as negative x minus 4. So this is going to be a parabola with upside down with intercepts at 0 and 4, and this is just our normal parabola y equals x squared. Where do these intersect each other? Well, I can set x squared equal to 4x minus x squared and just solve this equation, I suppose. So that becomes 2x squared minus 4x is 0, divide by 2, and okay, factor out an x, and this is what we get. Okay, so the answer is that these 2 curves intersect twice, when x is 0 at 0, 0, and when x is 2 at 2, 4. Okay, so now we can graph this, I guess. So here we go. Here is the origin. And then 1, 2, 1, 2, 3, 4. So way up here is one of the parabolas is going to look like, well, like that. And that's the parabola y equals x squared. And then the other one, it's going to have roots at 0 and 4. So it's going to come up like that. And yeah, that just has a relative max at 2, 4, I guess. Because yeah, it just does halfway between the intercepts. Okay, so there we go. I don't actually need any of this. What matters now to me is that I have this region. What is the region? It's this green shaded stuff right here. And to be sort of careful and organized about this point is 2, 4. This curve is y equals x squared, and this curve up here is y equals 4x minus x squared. Okay, and now now that I have this picture, I sort of go back to the problem and read more carefully what they're saying. What are they saying? We're supposed to be finding the volume of the solid formed when this region is rotated about the x-axis. Okay, so this entire shape that I have here is going to be rotated about the x-axis. And so first I should take a minute and sort of visualize, well, what happens as this shape gets rotated about the x-axis. So 1, 2, 3, 4, and I get whatever I get here. And okay, so we get a and a And the answer is it's going to be some kind of like thing. So this is going to be some sort of weirdly shaped kind of bowl, which is sort of parabolic on the bottom and parabolic on the insides as well. And my only hope for finding the volume of this bowl is to be able to split it up into an infinite number of infinitely thin things. And here, the only way that we're going to have any success is if we cut it vertically. Sort of perpendicularly to the axis of rotation. That's kind of the idea. And so, what I'm going to do is partition the interval from 0 to 2 up into subintervals, choose an arbitrary point x, and draw the representative rectangle. And the representative rectangle looks like this. And what happens to that representative rectangle as it gets rotated about the x-axis, what we get is this thing that we call a washer. And hopefully you got all this from the video. This washer kind of has got this type thing going on. So hopefully that's clear from the video. It should be. What I tried to draw in red is the shape formed when this rectangle gets rotated about the x-axis. And yeah, it's a washer. What's a washer? It's just kind of a nickname for this geometric object, which is in fact just a cylinder minus a cylinder. But it's a cylinder. But the shape is. But the cylinders are very, very short. So this is kind of a cylinder which is dx tall minus another cylinder which is dx tall. Okay, so let's just do this now. What do we need to? What we really need to be able to do is we need to find the area of that red shape, the area of that washer, and then its volume is going to be the area of that red shape times the thickness of the subinterval times the thickness of the washer, which is really just the height of the washer, which is just the width of the subinterval. So what do? I need to know both the inner radius and the outer radius because this red shape is really just a circle minus a circle. So what is the inner radius? Well, you have to just kind of say to yourself every time, I choose an arbitrary x value. In terms of x, what is the height of that, the bottom of this representative rectangle? Well, the y-coordinate of the bottom of that representative rectangle is just the point on the curve y equals x squared. Therefore, this radius is x squared. And for that same arbitrarily chosen x value on the x-axis, what is the height of the top of the representative rectangle? Well, it's just the y-coordinate on the parabola 4x minus x squared. Alright, so having done all that sort of thinking and understanding work, I now can start to solve the volume problem, which is I'm going to take the big circle, which has radius 4x minus x squared, and therefore its area is pi that squared. That would be the area of the big circle, and then we subtract the area of the little circle, and the area of the little circle is pi radius squared, but the radius is x squared squared. And so that expression I have on the board right now represents the area of this circle minus circle shape. And then I multiply this by the thickness, which is just dx. That now gives me the volume of one of these washers, and I integrate from 0 to 2 along the x-axis, adding up those infinite number of washers, adding up all their volumes to get the volume of the overall shape. So okay, that was just a lot of work, and now we still have an interval to do. So let's just kind of do it, right? What do we get? We can take a pi out. This needs to be dealt with. This is like, oh boy, 16x squared minus 8x cubed plus x to the fourth. But then this is minus x to the fourth. So I think I did that right. Just expanded things. Looking good. And I took out a pi, so from 0 to 2. So I get pi integral from 0 to 2 of, well, I can even take out like an 8 or something, maybe. if I take out an 8, I get 2x squared minus x cubed, and now we just do this integral, which doesn't look that hard anymore. So what do we get? Up a power, so that's 2x cubed over 3 minus x to the 4th over 4, evaluated at 2 and 0, and I multiply the whole thing by 8 pi. So 8 pi times, when I plug in 2 there, I get 16 thirds minus 16 fourths. There's no really good, well, it's just 4. Maybe this is just a better way to do it. And so, what's that? That's just got to be wrong, man. Oh boy, what did I do wrong? Inner radius, outer radius minus inner radius squared plus x to the 4 plus 16x squared minus 8x cubed. Take out, cancel, boom, boom. Some mistake is here somewhere. 2 to the 4th is definitely 16. No, there's no problem. Sorry, this is just 12 thirds. 16 thirds, sorry. Whew. 16 thirds is 4 is 12 thirds, so this is just 4 thirds. So this is 8 pi times 4 thirds. And so the answer really is 32 pi over 3. I bet that's right. Yeah, it is. Okay, good. We're half done with this problem. That was just 13a. Now I need to do 13b, which is just harder, I think. So let's erase everything because I'm gonna just make an entirely new picture. Since that one was so heavily annotated, but now I know everything, so this should go a lot faster. So let's see. Now we are going to be rotating around the line y equals 6. So, oh boy. Gotta be careful what I'm doing here. Yeah. So, like this or something. So now, here's 1, 2, 3, 4, 5, 6. Here's the line y equals 6. But the region is the same region. It's the region bounded by, which starts here at 0, 0, and goes to 2, 4, and there's this shape, which is y equals x squared, and there's this shape, which is y equals 4x minus x squared. And so now, the only thing that, so it's still the same graph, which I understand, it's still the same points of intersection, it's still the same region, but I'm just doing something totally different with that region now. I'm rotating that region about the line y equals 6. And when I rotate that region about the line y equals 6, just a completely different shape is formed. Now, this shape is going to, so here will be 8, I'll have like a point, and then I guess this is going to be up here at like 12, right? I'm going to have another point if I'm doing this right. So cha and sha. And so what we're going to get now is this kind of wild, now it's sort of a giant bowl with a kind of a hole in the middle or something like that. And the bowl is kind of parabolic on the bottom and again parabolic on the kind of inside. So it's very hard to visualize this, and okay, my art skills, they could be better, they could be worse, but they could be a lot better. What is the volume of this thing? Well, still my only hope to be able to find the volume of this thing is to split it into a bunch of infinitely thin slices. And now, once again, I'm going to slice vertically, perpendicularly to the axis of rotation. And once again, if you just break this up into sort of small problems, it's not that hard. I have a representative rectangle. Here is my representative rectangle. And I can find the volume of a kind of representative cut of this shape by finding the volume, by thinking about what happens to the representative rectangle as it gets rotated around the line y equals 6. And as it gets rotated, what we get is a washer. Okay, so again, geometrically speaking, I have this washer, which is really just a circle minus a circle. And if I can find the volume of this washer, then I can use integration to find the volume of the sum of all the washers. And what is this washer? It's just a circle minus a circle times the thickness of the washer, the height of the washer, which is just dx. So okay, so I just have to be able to do this kind of carefully. But I think some people do find this kind of hard, because now what's relevant, and this is why I think the picture is so important, what's relevant to finding the area of this circle minus circle is the inner radius of the circle and the outer radius of the circle. And so I need to find this, I need to find what this is. This is why I recommend kind of using curly braces here. So this is the inner radius, and sort of, maybe I'll do it like this, is the outer radius. Okay, so let's do the outer radius first. What is the outer radius of this circle? Well, the radius of the circle is the distance, the outer radius is the distance from the axis of rotation to the bottom of the outer edge of the representative rectangle, which in this case is the bottom of the representative rectangle. So the thought process goes something like this. I choose an arbitrary x value on the x-axis from 0 to 2. In terms of x, I know that this point right here has y-coordinate x squared, which is just another way of saying that's x comma x squared. But if x squared is that height, then since this is 6, from here to here is 6, and this is x squared, then this is 6 minus x squared. And thus, my representative rectangle will have outer radius 6 minus x squared for a given x value, for a given arbitrary x value. Okay, and now what's the inner radius? It's going to be, well, it's going to be the difference between, it's the difference in the y-coordinate. It's the distance from the axis of rotation to the top of the representative rectangle, but the top of the representative rectangle has height, measured from the x-axis, of 4x minus x squared. And thus, this inner radius is 6 minus 4x minus x squared. So you have to kind of go to the x-axis, you have to go up to the point, then you have to sort of say to yourself, oh, that's the distance from the x-axis to the top of the representative rectangle, but what I need is the distance from the axis of rotation to the top of the representative rectangle. So that's the entire distance from the x-axis to 6 minus that height. And so, okay, some people find this kind of easy, but some people find this kind of hard. Therefore, what should I be doing now? Well, I should be taking the outer radius, which is 6 minus x squared, multiply it by pi and square it. So that's pi r squared gives the area of the outer circle, and I need to subtract from that the area of the inner circle, which is going to be pi times the inner radius squared, which is 6 minus 4x plus x squared, and that will be, squared. So this now, everything on the board now, represents the area of a circle minus a circle, so the area of that red shape. And then I multiply it by dx, that gives me the volume of one slice, and then I integrate up the y-axis, up the x-axis from 0 to 2, so across the x-axis. Okay, so I think the picture is all the important thinking that's going on in this problem is happening on the picture, and in any sort of reasonable world now, you would just not actually have to do this integral, you would just stop and use technology or something like that. So that's a very reasonable thing to do, but anyway, here you are, I'm just gonna do it, I think. So let's go, without further ado, what is this? It's 36 minus 72 x squared plus x to the fourth, cha. And then minus, that's just what happens when you square 6 minus x squared, 36 And then over here, oh man. So I just happen to know from like life that if you square a trinomial, then just what you get is just a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac. Is that even true? Wait, give me a second. I'm suddenly doubting myself. Yeah, that just has to be true, right? Because you get a squared, then you get ab, then you get ac, but then you get ab again, and then you get b squared. So you're going to have, in general, you'll have 9 terms, but that reduces down to 6 terms. Okay, so this becomes 36 plus 16x squared plus x to the 4th, and now plus 2 times the product of those two, so that's 24x, so that's going to be minus 48x. Then plus 12x squared, and then minus 8x cubed. Okay, and I was kind of just locking in there and just refusing to be wrong, so I think that's just right. Okay, are there some cancellations? Well, I hope so. I hope so. The 36 is canceled, so that's nice. X to the 4th, the x to the 4ths cancel, so that's also nice. Within the parentheses on the right, I guess I get like a 28x squared. Yeah. And so, and I'm subtracting that. So I think what I'm left with, I've never done this problem before, all the way out actually, negative 72x squared, but then minus another 28x squared should give me, well, I'll just write it. And then plus 48x and plus 8x cubed. So, if you're following all this, and I almost hope you aren't, this is 8x cubed plus 48x, or rather, I guess I should write this maybe as minus 100 x squared, because that's what it is, plus 48x. And now that's maybe, not so bad. Pi integral from 0 to 2. Okay, I guess I can take out at least like a 4 from all of this, so to make these numbers a little bit smaller. So that's 4 pi integral from 0 to 2 of 2x cubed minus 25x squared plus 12x. And now I can just do this. What is it going to be? Up a power, so that's x to the 4th, divided by 4, so that's going to be over 2, minus 25x cubed over 3, plus the antiderivative of that is just going to be x squared. It's just going to be 6x squared. That is surely right. Yeah. And so 4 pi, and then all of that is happening at 0 and 2. Okay, so I'm just going to finish this off. When I put 2 in, I get 16 over 2 is 8. When I put 2 in here, I get 8 times 25, which is 200. Yeah. And when I plug in 2 here, I get 4, I get 24. And then the zeros are all 0. So what do I got here? 4 pi times 32 minus 200 over 3. That is definitely wrong. So that makes me very sad. Oh man, 36 months, starting all over again from scratch, minus 24, so then boom, and then boom, and then boom, 8 minus 8x cubed. Sorry. Okay, what's happened? 36 minus x minus x squared. Negative 7x squared minus 28, but then plus 48, and then plus 8x cubed. It's minus 100x squared plus 8x cubed plus 48x. Take out a 4. Anti-differentiate, up 4 divided by 2. Oh, no. 3 divided by 3, up 2, or 266 squared. 24, 16, oh man, I'm so sad. Maybe 8 times 25, 8 times 25 is, yeah, 4 times it was 200. So, why is this wrong? 60. Am I making, I hope it's just some kind of simple sign error. But maybe it's not.
Let me just see if the answer key offers anything. X cubed minus 5x squared. So I just made some algebra mistake, even though I swore I wouldn't.
Is it just really stupid? Is it just a really, really stupid? Oh boy. Ha 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 ha. Okay, that was terrible. So that's a 12. Oh my god. So that's just a 12, not 72. Where is that coming from? Okay, so there we go. This is all going to clear up now. So this is minus 40, not minus 100. That means that I can actually take out 8. And when I take out 8, I'm left with just 1x cubed. And this won't be 25 anymore, but will instead just be 5. And this will be 6. Okay, so this is now looking a lot better. And now this is x to the 4th over 4. And derivative of 5x squared is just 5x cubed over 3. And this is going to be 3x squared is the answer. Okay, so sorry about all that. And then that becomes 4 minus 40 thirds plus 12. That's looking a little bit better. So that's 16 minus 40 thirds. So that's 48 thirds minus 40 thirds. So that's 8 thirds. Okay, and so hopefully now the final answer is 64 pi over 3. Please be right. Alright, good. Okay, so I made a horrible, just arithmetic, stupid algebra 1 mistake, which is certainly possible, but anyway, I found it, and there we go. Okay, good. That was the second problem. I think they all go a lot faster now. Let's do some more that are a little bit easier. Hopefully you're watching this on 2 times speed, or not at all. Okay, 18. 18 says, find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the line y equals 4. Okay, so we're given y equals secant, and y equals 0, and we're doing all of this on the interval from